Hello everyone, learning Python can help you land a job with a great salary and benefits and lead to a rewarding and satisfying career. In various industries, Python developers are in high demand due to the language's widespread adoption. With Python expertise, you can work in fields such as web development, data science, machine learning, automation, and many more. Today's job market requires you to acquire Python skills in order to be competitive and secure great opportunities. So let's get started to understanding the basics of Python. Let's discuss where and how Python is used. Data analysis and visualization. Data analysis and visualization are two types of Python's most popular uses. Among the most popular Python libraries are NumPy, Pandas, and Matplotlib, which provide efficient tools for analyzing, displaying, and manipulating data. Using these libraries, you can clean and process data, perform a stats analysis, create interactive visualizations, and generate insightful reports. Machine learning and artificial intelligence. AI and machine learning have benefited greatly from Python's capabilities. The TensorFlow, Keras, and PyTorch libraries provide powerful frameworks for building and training machine learning models. The simplicity of Python as well as its extensive scientific computing support makes it well suited to tasks such as image recognition, natural language processing, and predictive analytics. Game development. Several Python libraries facilitate the development of games, including Pygame and Panda3D. Games can be created using these libraries in 2D or 3D. Graphics and audio can be handled and logic can be implemented. The great thing about Python and its rapid development capabilities is that it makes it an attractive option for prototyping and developing great games. Scripting and automation. Python's ease of use and readability makes it ideal for scripting and automation. Python scripts can automate repetitive tasks, perform system admin tasks, and streamline workflows. The Python standard library provides modules for interacting with files, databases, network, and more, making it a great choice for automating a variety of tasks. Software and hardware scripting. Python can be used for scripting tasks in software and hardware development. In general, it is used for test automation, software testing, and controlling microcontrollers and robots. Web development. Python provides frameworks like Flask that make web development easier. Developers can build scalable, secure, and feature-rich web applications using these frameworks. Developing websites, APIs, and server-side applications with Python is easy and fun thanks to its amazing libraries. Before we wrap up, let's take a mini quiz. What is Python used for? A. Web development. B. Data analysis. C. Game development. Or D. All of the above and much more. What do you think? If you picked D. All of the above and much more, you're absolutely right. Let's start learning Python now. Initially, we will discuss theory, then we will get into practical examples. First, you need to understand the syntax, and then you need to know how to use it. We will cover the following topics: basic syntax, conditional statements, functions, libraries, and frameworks. Just a quick note before we begin to learn how to code. When you speak a language like Spanish, English, or Chinese, you need to know the words and the grammar before you can effectively communicate with other people. Similar to that, before you can build or test with Python, you need to know a syntax, which is more than understanding its basics. You need to know how to use it to actually build it out. Let's learn how to download Python. Follow these steps. Number 1, open your web browser and go to python.org to visit the Python website. Python offers two versions, Python.2x and Python 3.x. As of 2023, Python 3.x is the latest stable version of Python. So as step 2, download the latest version. Step number 3, select the operating system on the Python website and you'll find options for various operating systems such as Windows, Mac, and Linux. Click on the appropriate operating systems based on your operating system. Step 4. You'll always be taken to a page where you can choose different options for installing the software after clicking on the download link. Please select the installer file that corresponds to your operating system and download it to your computer. For example, for Windows, download the Windows link. Step 5. Run the installer by double-clicking the downloaded installer file. Complete the installation by following the instructions provided by the installation wizard. Step 6. Open a command prompt, Windows or terminal for Mac and Linux, and type the following command to check if Python has been installed successfully. The version of Python installed will be displayed by this command. Check that it matches the version you downloaded. Well done. Python has been successfully downloaded and installed on your computer. Now you can write and execute Python programs. Now let's download PyCharm. PyCharm is Python IDE. IDE stands for Integrated Development Environment, which is a software application that helps programmers develop software code efficiently. To download PyCharm, you can follow these steps. Number 1. Visit the JetBrains PyCharm website. Number 2. PyCharm is available in 2 editions, PyCharm Community Edition, which is free, and PyCharm Professional Edition, which needs to be paid. Click on the download link for the edition that suits your needs. The PyCharm download page offers options for different operating systems depending on your operating system, Windows, Mac, or Linux. Choose the appropriate download link. Number 4. To download the installer, click on the link for the edition and operating system you selected. Your computer will begin downloading the installer file. Number 5. Download the installer file. Complete the installation process by following the instruction provided by the installation wizard. It may be necessary for you to have admin privileges in order to get the software installed on your machine. Number 6. You can launch PyCharm after the installation is complete by finding it in your applications or start menu. When PyCharm is open for the first time, you will be asked to configure some initial settings. Well done. PyCharm has been successfully downloaded and installed on your computer. For Python development, PyCharm can now be used as an integrated development environment. Now that we understand these steps, let's do a quick review of how it can be done. So first we're going to go to a browser and we are going to type Python download. This you have to go to the python.org site and here, download based on the operating system that you have. You can also browse through the website to get more information. As you can see, the installer has downloaded, so what I'm going to do now is I'm going to click on it and a wizard should pop up. You can read through this if you want, but I am just going to go to continue for the installation. And then multiple things come up, just mark it as continue. They're going to be asking for your admin information. Give them your admin information. Yep, it's just preparing some files. It will take around like 5 minutes for this to go through. After your files have been completed, as you can see, it's almost done. There should be Ubuntu resources popping up, which will show you Python files getting installed. Yep, as you can see now, Python has almost installed. It's just running the last few minutes. You see the IDE, the README. Now that it has installed, what you can do is you can mark it as complete and close everything out. Just make sure to keep this. Now what we're going to do is we're going to move on to downloading PyCharm. We're going to put JetBrains PyCharm here. As you can see, you can find it on Google browser. It has popped up. What you're going to do now is just browse to the site and see what other things are available. Now what you can see is that there are 2 types of PyCharm available. One is paid and one is free. We're going to go with the free edition. Click on download. It's just going to take some few minutes, but installation has started. In the meantime, all this is installing. Let's just talk about IDE. So IDE is really important because that is your environment where you're going to build, you're going to test before you actually release something out to the world. Now, what I really want to emphasize is that end user never sees your coding backend, your IDE environment. It always sees what you have developed and brought it to production. For example, if we look at Facebook, no one ever goes to facebook.com and sees like bunch of code. That doesn't exist. What does exist is that the actual website that has been produced. So just always keep that in mind while you're developing that IDE. Your environment is your environment to build, to make mistakes. But once it goes to production, that is the seriousness that will come. So while we were rating, I just wanted to bring that up so that it is in your mind. Okay, so now that it is installed, we're going to bring it into the applications file. So it is available to you. Yep, just few things happening to make it sure it's fully in your environment. Now what we're going to do is we're going to search PyCharm. It should be available for you to use. And it should open PyCharm Community Edition. As you can see, it's opening up. The fact that it's showing up and it's opening up, that is a good sign. Just give it another moment. It's going to start. First time it might take a little longer, but once you start to use it, it's just going to be like seconds. So PyCharm is opening up. Yes, say agree. Now let's create a new project. Yep, next. Remember you're gonna have like a lot of projects, so that is why it asked you where you want this particular project to be installed. Now let's go to the terminal. In the terminal, what we're going to check is what version of Python do we have. So go to terminal. We're gonna put the command python -- version. And if it shows us the version, this means that it has successfully been installed. Okay, everything is working great. We're going to learn about comments. Python code can be explained using comments to a human. It is not code. Code can be made more readable by using comments. Use this symbol for the single-line comments and triple quotes for multi-line comments. Indentation. Unlike other programming languages, Python uses indentation, white space, to define code blocks. Code lines are indented with spaces at the beginning. Variables. The Python language does not have a command for declaring variables. Variable types are determined at runtime in Python, which means variables are created when they're first assigned values within the code. A variable is a container for storing data values. Let's talk a little bit more about variables and how to name them. Variables can have short names like X and Y, or descriptive names, age, customer name, total revenue. Rules for Python variables. Variable name must begin with the letter or underscore. Variable names cannot begin with the number. Variable names can only contain alphanumeric characters and underscores. The names of variables are case sensitive. Python variables cannot have keyword names. Python allows you to assign values to multiple variables in one line. The good thing about Python is that it allows you to assign values to multiple variables in one line, which saves you time and speed. Global variables. Variables that are created outside of a function and can be used throughout the code and program. We will learn more about functions soon, but right now let's focus on variables. Global variables can be used by everyone, both inside of functions and outside. Non-global variables are specific to only inside of the functions, and they have no meaning outside the function. Data type. A data type is an important concept in programming. Different types of variables can store different types of data. In simple terms, data is organized into categories to better use, understand, and process them. By default, Python provides the following type. Text, strings. Strings are sequences of characters enclosed in quotation marks, either single or double quotes. Symbols, letters, digits, and white space can all be used as characters. In most programming languages, including Python, strings are fundamental data types. The purpose of them is to represent and manipulate textual data. Strings can store words, sentences, paragraphs, and even entire documents. Let's play with strings a little bit. Let's print some strings. As you can see, we created a string variable and printed using print function. There are also the following. Upper method returns a string in uppercase. Lower method returns a string in lowercase. The split method splits the string into substrings if it is finds instance of a separator. You can extract a portion of a string using slicing. Slicing allows you to obtain a substring by specifying a range of indices. You can determine the length of the string, the number of characters it contains using the len function. Numbers. Python has 3 built-in numeric data types: integers, floating point numbers, and complex numbers. Int. An int is a whole number, positive or negative without decimals with no limits. Float. Float or floating point number is a number, positive or negative, containing 1 or more decimals. Complex. In Python, complex numbers are a built-in data type used to represent numbers with both a real and an imaginary part. The complex number type is denoted by using the complex keyword or by specifying the imaginary part with the I or J suffix. Sequence types. The sequence data type in Python is used to store in an organized fashion the sequence data. List. Lists are used to store multiple types in a single variable. A list contains items separated by commas and enclosed within square brackets. Lists are mutable, meaning you can add, remove, or modify elements after creating them. Even if the data is in a list format, you can access them individually by indexing. List items are indexed. The first item has index 0, the second item has index 1, etc. Lists are 0 indexed, so the first element has index of 0. The length function gives the length or the number of elements in the list. There are many types of data that can be contained in a list, such as numbers, strings, booleans, and even other lists. As a result of their flexibility and dynamic nature, Python lists are widely used in a variety of applications. Tuple. A tuple is another built-in data structure that is similar to a list. However, unlike lists, tuples are immutable, meaning that once created, their elements cannot be modified. Tuples are represented by comma-separated values enclosed in parentheses. They are often used when you want to store a collection of values that should not be modified. They can also be used to represent a group of related values where the other and structure of the elements are required. Boolean. The Boolean data type represents truth values. There are 2 Boolean values, true and false. Booleans are used in logical operations, conditional statements, and control flow to determine the flow of execution based on certain conditions. Boolean values can also be the results of comparison operators such as equal, not equal, greater than or equal to, less than or equal to, which compares two values and returns a Boolean result. Programming relies heavily on Boolean values, which allow you to control the behavior of your programs based on specific conditions. To summarize, data types are important because data is a critical aspect of the coding process. Note, the type function returns the type of the object and it will help you understand the data type of variables while coding. Conditional statement. You can use conditional statements in Python to control the flow of your program based on certain conditions. Python's conditional statements include if, elif, short for else if, and else. You need to know these things about Python conditional statements. The if statement. The if statement executes a block of code only if a specific condition is met. Using the if-else statement, you can execute one block of code if a condition is true and another block if the condition is false. The if, elif, else statement. This allows you to test multiple conditions and execute different blocks of code depending on which condition is true. Nesting conditional statements. It is possible to nest conditional statements within each other to create more complex decision-making structures. Using this method, you can check multiple conditions and perform different actions based on the results. The code blocks within condition statements should be properly indented using spaces or tabs. Indentation determines the scope of the code block in Python. This helps to serve conditional statements in Python. Making decisions based on conditions is essential to controlling the flow of your program. Functions. The concept of Python functions is fundamental to programming. Here's what you need to know about Python functions. Number 1. Function definition. The term function in Python refers to a block of reusable code that performs a specific task. In addition to a name, it may have parameters which are optional and a return value which is optional as well. Definitions of functions are made by using the def keyword followed by parentheses and the function name. Number 2. Function syntax. Def function name parameter 1 parameter 2 is an example of how definitions are set. Function body has a code block and perform actions. This is basically the work that is getting done by the function. And there's an optional return value as well. Number 3. Function parameters. Parameters are placeholders for values that can be passed to functions. By using them, you can make your function work with a variety of inputs. During the definition of a function, parameters are enclosed in parentheses. Number 4. Function arguments. When a function is called, arguments are passed to it. The parameters in the function correspond to these values. When a function is invoked, arguments are provided inside parentheses. Number 5. Return statement. When a function returns a value, it uses the return statement. In the statement, you can pass back a result that has been calculated inside the function. By default, if there's no return statement, the function returns none. Number 6. Function call. In order to execute a function, you must call it by its name followed by parentheses. The arguments are provided inside parentheses if the app function has parameters. Number 7. Scope and global variables. It is important to know that functions introduce their own scope, which means variables defined within them cannot be accessed outside of them. It is possible, however, to access global variables from within a function. Number 8. Default arguments. Function parameters can be assigned default values. A default value will be used if no parameters provided when calling the function. Number 9. Arguments of variable number. Using Python special syntax, you can define functions and accept variable numbers of arguments. Args can be used for non-keyword variable length, and then there is the keyword variable length arguments. Number 10. Recursion. Python functions can be recursive, which means they can call themselves, solving problems that can be broken down into smaller parts, can be made easier with recursive functions. Number 11. Function documentation. The purpose, parameters, and return value of a function should be documented with a docstring, which is a multi-level comment. You will be able to understand how to use the function more easily. Using Python functions, you can organize and structure your code, promote reuse, and make it easier to read. Modules and packages. Modules and packages are used in Python to organize and manage code into reusable and logical grouped components. Python provides a rich library of modules and packages for various functionalities. Here's what module and packages are and how they work. Number 1. Modules. Modules contain Python code defining functions, classes, and variables. The module is designed to be imported and used in other Python programs. It is easier to organize code with modules and to reuse it with modules. Using the import statement, you can use them. The from key can also be used to import specific functions or variables from a module. A module from a package must be imported using dot notation. Here are some examples. Number 2. Packages. Packages organize related modules into a directory hierarchy. This directory contains multiple Python modules as well as init.py file. Init.py indicates the directory should be treated as a package. By using packages, you can organize modules into subdirectories and provide a hierarchical structure for your code. As a result, naming conflicts can be avoided and large projects can be managed more easily. There's also a special line file called init.py that contains the package's initialization code. When the package is imported, this file is executed. Also keep in mind, you can create a directory and include an init.py file in it to create your own package. By creating Python files within the package directory, you can add modules to the package. Modules and packages help you organize your code into logical units, promote code reuse, and create more maintainable and scalable Python projects. Here are some examples. File handling. Python's file handling involves reading and writing files. Python offers several ways to handle files. The following are the basic operations. Number 1, opening a file. Using the built-in open function, you can open a file path, and a mode. For example, read, write, append are required. Number 2, reading from a file. The read method allows you to read the contents of a file. The entire file's content is read as a string. If you wish to read a line at a time, you can use read line. Don't forget to close the file when you're done. Number 3, writing to a file. The write method can be used to write to a file. The file can be written with a string. The file will be created if it does not exist. The previous content will be overwritten if it exists. Number 4, appending to a file. You can append content to an existing file by opening it to append mode A instead of write mode W. The write method will then add content to the end of the file without overwriting it. Number 5, closing a file. After you have finished working with the file, it's essential to close it. To release file resources, use the close method. When you have done, the statement will automatically close the file. In summary, it is important to handle exceptions when working with files, as file operations can raise errors. During the file handling operations, it is a good idea to use exception handling using try and except codes. This is a basic overview of how files are handled in Python. In addition, there are more advanced methods and techniques available, such as working with binary files or using the OS module. Error handling. The ability to handle errors is a crucial part of writing Python code that is robust and reliable. The following are some key points to remember about Python's error handling. Number 1, exception types. Exceptions are used in Python to handle errors in exceptional situations. Code exceptions are raised when errors occur during exception. There are a wide range of built-in exception types in Python, including value error, type error, file not found error, etc. You can handle specific errors more effectively if you understand the different exception types. Number 2, try except blocks. Try except blocks are the most common way to handle exceptions. The try block contains code that may raise an exception. If that exception occurs, it is caught by the corresponding exception block based on the exception type. To handle different types of exceptions, multiple exception blocks can be used. With the exception block, exception can be handled gracefully and necessary actions can be taken. Number 3, handling multiple exception types. An exception block can handle multiple exception types if you specify them as tuples. Number 4, handling all exceptions. You can use a bare exception block to catch any exception regardless of its type. To prevent unintentional hiding errors or masking unexpected exceptions, it is generally recommended to be more specific about the exceptions you want to catch. Number 5, handling specific exceptions. An exception block without an exception type at the end can be used if you need to handle a specific exception type, but you also want to catch all other exceptions. In this block, any exception not caught by preceding specific exception blocks will be handled. Number 6, the else block. If there are no exceptions in the try block, then the else block is executed. It allows you to define code to run when the try block succeeds without throwing any exceptions. By doing this, we can separate the error handling logic from the normal flow of code. Number 7, the finally block. The finally block is always executed regardless of exceptions. It defines code that should be executed regardless of the situation, such as releasing resources or performing cleanup operations. If an exception is thrown or an early return statement is made, the finally block ensures certain actions are taken. Number 8, raising exceptions. Raising exceptions explicitly is possible with the raise statement. With this feature, you can create custom exception types or raise built-in exceptions with custom messages. When you encounter an error condition that needs to be handled at a higher level, you can raise an exception. Number 9. Logging exceptions. It is often helpful to log exceptions for debugging or troubleshooting purposes. In addition to handling them, Python's logging module provides powerful logging capabilities that allow you to record exception information and other relevant details. To summarize, it is important to understand these concepts and best practices related to error handling in Python in order to write code that gracefully handles exceptions, provides useful feedback, and improves application reliability. Object-oriented programming. Object-oriented programming organizes and structures your code around objects, which are instances of classes. Python supports OOP fully, and here are some key concepts and features you should know about it. Number 1. Classes and objects. A class defines the properties, attributes, and behaviors, methods that objects belonging in that class will possess. Objects are instances of classes. Instances of a class can be created by using its name, followed by parentheses. Classes can be public, private, protected. Number 2. Attributes and methods. All instances of a class share class attributes, which are variables defined within a class. Each instance of the class has its own instance attributes. Classes define their behaviors through methods, which are functions defined within them. Attributes of a class can be accessed and modified by them. The first parameter of instance method is self, which refers to the instance itself. Number 3. Inheritance. Inheritance allows you to create a new class, derived class, or subclass that inherits properties and behaviors from another class. It is possible for the derived class to add or overdrive attributes and methods as needed. Number 4. Encapsulation. In encapsulation, the internal details and implementation of the class are hidden, and data and methods are accessible through well-defined interfaces. It ensures data integrity and code maintainability. To indicate the intended visibility of attributes and methods in Python, use underscores. Number 5. Polymorphism. Here, objects of different classes are treated as objects of a common base class. So, as long as they are implemented, the required interface or method signature, methods can be called on objects without knowing their specific types. As a result of this, code can be more flexible and adaptable. Number 6. Method overriding and overloading. By overriding a method defined in the base class, a derived class can be provided of different implementation. In a class, method overloading refers to the definition of multiple methods with the same name but different parameters. You can achieve similar behavior in Python by using default argument values or by using args and kwargs to accept a variable number of parameters. To summarize, these are some of the fundamental concepts of Python object-oriented programming. It is possible to write more organized, modular, and reusable code by understanding and utilizing these concepts. Libraries and frameworks. In Python development, libraries and frameworks simplify the process of building applications by providing pre-written code, tools, and abstractions. To get started with Python libraries and frameworks, here's what you need to know. Libraries. A library is a collection of modules or packages containing reusable code. You can use libraries to perform specific tasks without having to reinvent the wheel by importing their functions, classes, or methods into your own code. Python has a vast ecosystem of libraries covering a variety of fields such as NumPy for numerical computing and array operations, Pandas for data manipulation and analysis, Matplotlib and Seaborn for data visualization, requests for making HTTP requests, SQL, Alchemy for working with databases, TensorFlow and PyTorch for machine learning and deep learning, Django and Flask for web development framework. Installation and usage. A library is typically installed using a package manager like pip. To install the Pandas library, you would run pip install pandas in your terminal or command prompt. With the import statement, you can import the library into your Python code, such as import pandas as pd. Frameworks. Frameworks provide a foundation for building applications by providing reusable libraries, tools, and conventions. The framework defines overall structure and flow of an application and provides abstractions and patterns that streamline development. Here are a few examples of Python's web development frameworks. Flask, a lightweight framework that allows the model view, root, pattern, and provides a simple yet flexible approach to building applications. Pyramid, a general-purpose web framework that aims for simplicity, flexibility, and scalability. Fast API, a modern high-performance framework for building APIs with automated data, validation, and documentation generation. Installation and usage. Frameworks can also be installed via PIP, just like libraries. Flask, for instance, can be installed using pip install Flask. After installation, you can start building applications by following the framework's documentation and utilizing its benefits and conventions. To summarize, here are the key benefits. Using libraries and frameworks, it saves developers time and effort by providing pre-written code and components. Frameworks offer built-in tools, patterns, and abstractions that streamline development and make complicated applications easier to develop. Python has a rich ecosystem of libraries and frameworks, backed up by a large developer community. As a result, you can leverage existing solutions, get support, and contribute to open-source projects. Libraries specialize in specific tasks or domains, allowing developers to use specialized functionality without having to implement them themselves. Libraries and frameworks offer support extensions or plugins that allow developers to customize and enhance their functionality. Although libraries and frameworks are powerful tools, it's important to choose and use them wisely according to your project needs. To ensure proper installation, usage, and best practices, always refer to the official documentation and community resources. Documentation and community. Documentation and community are vital aspects of the Python programming language that provide resources, support, and opportunities for learning and collaboration. Here's what you need to know about documentation and the Python community. Documentation. Number 1, official documentation. Python's official documentation covers the language itself, standard libraries, and various tools. It explains Python effectively, gives tutorials, and gives examples. Visit the docs.python.org to access it. Number 2, library and framework documentation. Library and framework documentation explains their usage, features, and API references. To understand how to use a framework library correctly, you should refer to the official documentation, like Flask, NumPy. Python community. Python Software Foundation is a not-for-profit organization that supports and promotes Python programming. In addition to managing the Python community, the organization organizes events such as PyCon. Number 2, Python Package Index. Python's official package repository, PyFull, hosts thousands of third-party libraries and frameworks. It simplifies the process of installing packages and allows developers to share their code. Number 3, forums and mailing lists. There are several online forums and mailing lists where Python developers can ask questions, seek assistance, and engage in discussions. Python mailing lists, Python, Reddit, and Python Discord are among the most popular. Number 4, conferences and meetups. It is possible to meet fellow Python learners and developers by attending talks and workshops, and really to network with Python professionals at Python conferences like PyCon, PyData, and regional and local meetups. Number 5, online learning platforms. For learning and improving the Python skills, there are many online platforms such as pythons.org tutorial section, Free Code Camp, W3 School. Number 6, open source projects. Numerous Python projects are hosted on platforms such as GitHub, which has a variety of open source community. Open source projects are a great way to learn, collaborate, and gain practical experience. You can greatly enhance your Python journey by staying up to date with news and developments, participating in the Python community, and leveraging the resources available to you.